For any assignment-related queries, call us at +1 678 648 4277. You can mail us at support@mathhomeworksolver.com or reach us at https://www.mathhomeworksolver.com. Problem 1. Which of the following are meromorphic in the whole plane? A. Z5. B. Z5 division/2, C. E1 division/2, D. 1 division/sin, Z. Answers. Meromorphic means analytic except for poles of finite order. A. Yes, this is entire. B. No, this requires a branch cut in the plane to define a region where it's analytic. C. No, the singularity at z equals 0 is an essential singularity, not a finite pole. D. Yes, sin, z, has simple zeros at for all integers n. So 1 division/sin, z, has simple poles at these points. Problem 2. Mathhomeworksolver.com. B. Find the number of roots of g, z, equals 6z4 plus z3 minus 2z2 plus z minus 1 is equal to 0 in the unit disk. C. Suppose f, z, is analytic on and inside the unit circle. Suppose also that f, z, 1 for z equals 1. Show that f, z, has exactly one fixed point f, z0, equals z0 inside the unit circle. D. True or false, suppose f, z, is analytic on and inside a simple closed curve y. If f has n zeros inside y, then f, z, has n-1 zeros inside y. Answers. A. By the argument principle, in this case, the zeros of f inside y are 2, 0 of order 2 and 3 respectively. The poles inside y are -1 and 1 of order 3 and 4 respectively. So, the integral equals B. On the unit circle z3 minus 2z2 plus z minus 1, 5 and 6z4 equals 6. Therefore, by Rush's theorem, the number of zeros of g, z, inside the unit circle is equal to the number of zeros of 6z4, i.e. 4. C. Let g, z, equals f, z, minus z. We want to show g has exactly one root inside the unit circle. We know f, z, minus z equals 1 on the unit circle. So by Rush's theorem, g, z, and minus z have the same number of zeros in the unit disk. That is, they both have exactly one such zero. Q.E.D. Mathhomeworksolver.com. D. False. Consider f, z, equals ez minus 1. This has 3 zeros inside the circle, z equals 3, 0, plus or minus 2. But f, z, equals ez has no zeros. Problem 3. Let a equals z 0 less than or equal to re, z, less than or equal to division/2, im, z, greater than or equal to 0. Let B equals the first quadrant / show that f, z, equals sin, z, maps a conformally onto B. Answers. A. You should supply a picture of the regions A and B and develop a picture tracking the argument we give. We see where f maps the boundary of A. The boundary of A has 3 pieces. So, the image of piece 1 is the positive imaginary axis, piece 2, z equals x, with 0 less than or equal to x less than or equal to division/2. On this piece sin, z, equals sin, x, so the image runs from 0 to 1 along the real axis. Piece 3, z equals division/2 plus I, with y greater than or equal to 0. On this piece. Mathhomeworksolver.com. So, the image of piece 3 is the real axis greater than 1. We have shown that f, z, maps the boundary of A to the boundary of B. To see that A is mapped to B, it's enough to verify that one point inside A is mapped to a point inside B. There are lots of ways to do this. Here's one. We know Pick x equals division slash 4 and y so large that e minus y is very tiny. Then, this last value is clearly in the first quadrant, I.E inside B. MathHomeworkSolver.com